All right, module 7.1, finding rational solutions of polynomial equations. We've talked about some polynomials and we've looked at what their graphs look like and what happens with that. So we are going to start with actually the equations and solving them. So the zeros, roots of a polynomial function, are factors of the constant of the polynomial function. Remember, a constant is something without a variable. So all it's saying is that the answers to a polynomial equation are actually going to be factors of that constant term. And we're going to do like a little kind of experiment to kind of get you to understand what this is saying. So we have this example, if f of x equals x plus 2 times x minus 1 times x plus 3, we can use the zero product property to find the roots, to find the zeros by setting each of these factors equal to 0 and solving it. So this would be x equals negative 2, x equals 1, x equals negative 3. Because remember, we do the opposite to move it across that equal sign. We can actually look at what the polynomial function really is in standard form. And when we put it in standard form, we can actually look at what that constant is so that we can see if these values here are truly factors of what that constant is. So the first thing we're going to do is we're actually going to multiply these together. And I'm going to use FOIL this time. I know yesterday or the day before we used the box method. We're going to use some FOIL. So that's x squared. That's plus 2x minus 1x and then minus 2. When I clean that up, I get x squared plus x minus 2. And I'm going to multiply that times x plus 3. And again, I'm going to go ahead and use FOIL. So I have x, or not FOIL, but distributive, cubed plus x squared minus 2x. And then I'm going to distribute the 3, plus 3x squared plus 3x and a minus 6. Now, I know I kind of squeezed that in over there, but we're going to go back and we're going to write this out. So that's x cubed, combining my x squared, that's plus 4x squared. Combining my x's, that's plus x, and a minus 6. Now, this minus 6 back here, that is the constant. And I want you to look at what those answers are. If we look at the answers, let's see if I can make this so you guys can kind of see it. Okay, maybe not. So x minus 2, x equals 1, and x equals negative 3. Negative 2, 1, and negative 3 are all factors of that negative 6. They're all factors of that constant term. So let me go ahead and rewrite the equation. I know it's kind of hard maybe to see, so I'm going to rewrite the equation that we got right here. And this is our constant term. So if we're looking at these values, the zeros, the roots, they are factors of that last term. And that's what this little thing up here means. Now, we're going to look at a theorem, and theorems can be kind of confusing, but we're going to look at it, and then we're going to apply it, and I'm going to show you how to use it. So, we're going to move a little bit onward. Finding zeros using the rational root theorem. It says, if p of x is a polynomial function with integer coefficients, means the numbers in front of the variables are integers, and if m divided by n is a 0 of p of x, then m is a factor of the constant term of p of x, and n is a factor of the leading term. So we're going to look at the beginning term and the constant, and we're going to combine them to find out what our zeros are. This can be kind of confusing. I'm going to show you how it applies. These are the directions for the examples we're going to do. So it says find the rational zeros of the polynomial function, then write the function as a product of factors. Make sure to test the possible zeros to find the actual zeros of the function. It's a lot of things. So we've got 3 things going on. So we're going to actually look at this problem over here. And I know there's some of you going, I'm not quite sure what that all means. I'm going to show you how to apply it. We're going to be great and fine. So here's the function we're going to deal with. We need to actually find the rational zeros so that we can factor it. That's the whole point of this, is we want to be able to factor it, because not everything can be done by grouping, so we have to have other methods in order to factor. So let's look at this. The number in front of the x cubed is a 1. That's our n value. M is the constant back here. And what this says is if we take all the factors of the m and all the factors of the n, and we write them over each other, then we can actually come up with a group of numbers we can test to try to factor. Sounds like a mouthful, but here we go. So m, we're going to simply write the factors of 20. We can have a positive or negative 1, positive or negative 2. 3 doesn't go into 20. 4 does. We could have a plus or minus 4. We could also have a plus or minus 5. 6 doesn't go, 7 doesn't go, 8 doesn't go, 9 doesn't, but 10 does. And then our last one could be a plus or minus 20. Now, we're going to list the numbers that multiply to n. Well, that's easy. The only thing that multiplies to n is plus or minus 1, because it's 1. So now we've got our list of values. We need to take every m value divided by n. And I know it seems like it might be a lot, but think about it. If I actually take all those values on m divided by 1 or negative 1, I'm really not changing anything. So for this one, we simply get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. We get the same value as m. We are going to test all of these values until we come up with one that actually works. Now, if you guess really good and you test the first one, you don't need to keep going. You don't have to test every single one. We just got to keep testing them until we find a value that goes and works. Now, we test these by using that synthetic division. So I'm going to go ahead and start with positive 1. I'm going to use the positive one. And I'm going to use that synthetic division to check. So, remember, I'm using synthetic division. The first term drops down. I get 1 times 1 is 1. Add these together, that's 3. 1 times 3 is 3. That's negative 16. Multiply, that's negative 16. Add them up, that's negative 36. Not the answer we're looking for. We want that answer on the end to be 0. We don't want a remainder, which would tell us it's a factor. So I don't know, let's try negative 2. Drop down that 1. So that's negative 2. Ooh, there's a 0. Negative 2 times there is 0. That's negative 19. Ooh, wait a minute. That's positive 38. I get 18 as a remainder. Not going to work. So I need to keep testing. But I can do this. I can say, okay, positive 1 didn't work. Negative 2 didn't work. That does not mean that positive 2 wouldn't work. So we can test 2. And I'm just creating some space. I didn't do negative 1 yet either. But that's 2. There's 4. That's 8. There's negative 11. Negative 22. That's negative 42. That's still not going to work for us. So I'm going to try another value. So I now know that 2 is completely not going to work. So I don't know. Let's try 5. See if we can get 5 to work. Or better yet, let's try, I don't know, negative 4. Why? I don't know, just trying it. There's negative 4. That is a negative 2. That's an 8. It's a negative 11. Oop, that's a positive 44. I don't really care what the answer is. The fact is, the answer did not come up 0. So that one doesn't work. Let's try negative 5. Just to try it. See. 1. There's negative 5. There's negative 3. There's a positive 15. There's a negative 4. Positive 20 means a remainder of 0. We're done. I don't have to test anymore. Winner, winner. This guy saves us. Now, we're not quite done with the problem. And you can see how this can be very tedious. But the more you do these, the better guessers you'll be, and you'll start to figure out some patterns here, and you'll be able to come up with those answers sooner. So what this means is I have 1x that's negative 5. But this right here, remember, this translates to x squared minus 3x minus 4. And I need to keep factoring that. So we're going to go again. That's x, but I don't need to do the p over q because it's a squared, and we've practiced our factoring. I need a positive and a negative. I have 1 times 4 and 2 times 2. The only way I can subtract those numbers and get a 3 is the 4 and the 1. And I want a negative 3. If I have 1x, that's negative 4x. So I have done the first part of the directions that said find the rational zeros and then write the function as a product of the factors. So what we want to do is we want to say f of x, because that's what our problem was, equals, notice this is x minus 5, so I'm going to rewrite that as x plus 5. So the product of the factors is x plus 5, x plus 1, and x minus 4. My zeros are negative 5. Let's see, let's write that as x equals negative 5, negative 1, and a positive 4. That is the answers. This is our possible answers. And we've done everything it's asked us to. We're going to try this on another one. We're going to try another function, and I'm going to make some room up here. So bear with me for just a moment. So we're going to do number 2. And f of x equals x to the 4th minus 4x cubed minus 7x squared plus 22x plus 24. All right. So we've got some big values up here, and it's a 4th power. My m is 24. My n is 1. The number here, number here. We left out this n is only 1, so my possible numbers for n are negative plus or minus 1. 24, we get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. So the bigger the number, the more choices you're going to have. And we need to rewrite my m over n. Well, since I'm only dividing by negative 1 or positive 1, they're not going to change. We'll look at some tomorrow in class where they do change and we have a number there instead of just 1. Now, we are going to start testing. So, I don't know, we're going to pick a value to test with. Let's start with 3. Why? I don't know. I feel lucky about 3. Maybe I'm wrong. So, again, synthetic division to test our choices. Drop down the 1. 3 times 1 is 3. Add these together, it's negative 1. There's a negative 3. That's negative 10. 3 times negative 10 is negative 30. Add them together, I get a negative 8. 3 times negative 8 is a negative 24. Got lucky. So there's our zero remainder. I do need to rewrite this. This becomes x cubed minus x squared minus 10 minus 8. Now, because it is a cubed, I actually have to factor some more. I forgot my x here. So I have to keep going. I can't stop yet. I have to do that m over n whole thing again. But the nice thing is, 8's a much smaller number. I don't have nearly as many factors of 8 as I do of 24. N is still plus or minus 1, so my n over n is a plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now, I feel lucky about the number 4, so we're going to test 4. So plugging in, I don't go back to this one. I have to use this equation. So that's 1, a negative 1, a negative 10, and a negative 8. Again, synthetic division. Bring down that 1. 4 times 1 is 4. Add these up, we get 3. 4 times 3 is 12. Add these up here, we get 2. 4 times 2 is 8, and a remainder of 0. I still have a lot of values there, but we are now down to a quadratic, which means I can actually factor. So I'm going to create a little space with our problem up here. I don't want to erase too much. I know that one of my answers was x equals 3. I know another one of my answers was x equals 4. And then down here, I have x squared plus 3x plus 2. And I need to factor this. That's x, both positives. Numbers that multiply to 2, that's simple. It's 1 and it's 2. There's no other options. So that gives me my other two answers. X equals -1, x equals -2. And I can write this as a product of the factors. So f of x equals x minus 3, because remember, it's going to be the opposite, x minus 4, x plus 1, x plus 2. So we have factored it. We have written as a product of the factors. We found the actual zeros. We found the possible choices in each case. Now, one last example that we're going to do is a word problem. So please write the word problem down. A box company is designing a rectangular gift container. The marketing department has designed a box with 2 inches shorter than its length and a height that is 3 inches taller than its length. The volume of the box must be 56 inches cubed. What are the dimensions of the box? So the first thing is we have to look at what volume means. And the fact that volume is length times width times height. Oops, that's kind of a funky looking W. Well, we need to define what the height is and what the length is and what everything else is. So the length we're going to define as our x value, because it's the thing that's constant in both. It says the width is 2 inches shorter than the length. So that means the width is x minus 2. And that the height is 3 inches taller. So that's x plus 3. So our volume then becomes x minus 2, x plus 3. And we know that that volume actually has to be 56. So we need to actually, to be able to solve a quadratic, we have to set it equal to 0. So we're going to do a little foiling here. That's x squared minus 2x plus 3x minus 6 equals 56. We're going to simplify things. We're going to set it equal to 0. And I get x squared. That's a plus x, combining my like terms. And that's a minus 62. So, I apologize. We got to go back. I made a mistake. I have to actually distribute that x. I forgot about the x there. So let's go back to this step. Before we move the 56, we got to distribute the x. So that's x cubed minus 2x squared plus 3x squared minus 6x. Much better looking problem. Combine your like terms. We're going to subtract 56 both sides. And I'll combine my like terms. So now I get the 0, x cubed plus x squared minus 6x minus 56. That looks much better. All right, so same thing. We got to figure out the values of x, so we need to do the m and the n. The problem is m is 56. N is just 1. So my values of m over n are going to be simply the m values. So I get a plus or minus 1, plus or minus 2, plus or minus 4. Trying to make sure you guys can still see this. Plus or minus 14, plus or minus 8, plus or minus 7, plus or minus 28, and plus or minus 56. So quite a few of them there. We're going to test the value of 4. And so we're going to get 4, and we're going to use 1, 1, negative 6, and negative 56. Drop down the 1. 1 times 4 is 4. Add them. 4 times 5 is 20. Add it. And 4 times 14 is positive 56, so I get a remainder of 0. So I am going to go ahead and erase the problem up here, this word problem, so that I have room to show you guys what we're doing. So one of my answers is x equals 4. Now, if x is 4, I can find my other dimensions. That means my width, this would be the length. The width, it said, was 2 inches left. So the width would be 2 inches. And the height is 3 inches more, which means the height would be 7 inches. We're done. We found the dimensions, the length, the width, and the height of the box, and we're finished.